Right. So our physics question now is interesting. Imagine a shot putter who throws the shot to the field with about the mass of 7.3 kilograms with an initial speed of about 14.4 meters per second at a 34-degree angle to the horizontal. Now our task here is we'll be calculating the horizontal distance traveled by the shot if it leaves the athlete's hand at a height of 2.1 meters above the ground. So it's also important here in doing physics question to visualize it to the real life scenario. So I have here a drawing in which we have also our pin that is shot putter, and then it throws it at about 34 degrees angle and goes to the ground. Okay, now here we have our some of our given, in which we have first we have our height of about 2.1 meters, and then with our angle of about 34 degrees, and then with our initial velocity also of about 14.4 meters per second in here. And also, actually, the 7.3 kilogram is negligible because any weight that you're going that goes to free fall will already be cancelled by its own inertia. Okay. Now here, if I'll be writing this down, our given here is our mass first is about 7.3 kilograms, and then our initial velocity is about 14.4 meters per second. Our angle theta here is 34 degrees, and our height is about 2.1 meters. And what we'll be finding out is our horizontal distance, which is our L. That is our question here. Okay, so what we will do, our prerequisite that we will need to do is our horizontal and our vertical component of our velocity. So what we'll be doing now is we have these arrows for horizontal and arrows for the vertical. So this is now our v sub x here, velocity on the x-axis and velocity on the y-axis. Actually, we have our formula for that, which is our velocity on the x-axis is equivalent to our initial velocity, cosine theta. And here our velocity for the y-axis is initial velocity, that is sine theta here. Okay. So now we'll be solving that one with our velocity x and velocity y. So now we can plug in our numbers in here. We have our v sub x with 14.4 meters per second with our cosine 34. So our result for that
11.94 meters per second.
and that is our x component on our velocity for the x component, and now for our y component also our velocity is still, we will substitute this one about 14.4 meters per second, then have this one as sine 34. Okay, our resulting number for that will be 8.05 meters per second. Okay, so let us proceed now to our formula to get the time, because we don't have the time and we need that to plug in also our numbers to get our horizontal distance. Okay, so let's proceed. Now, to get our time is we need this formula in here, which is t is equals to, that will be p sub 0, it's a negative sign, that will be sine theta in here, it's plus minus, now square root of v squared, that's our initial velocity, with sine squared theta, it's plus 2gh. Extend this one, and that's kind of, let's erase some part of it. Okay, and then place our sign right there. So it turned out so negative g. And then to continue, we'll be plugging our numbers here. We have 14.4 meters per second. That's a negative also. So here, and we'll multiply it with our 0.56. Then now we'll be using the minus here. It's a negative, and then we'll have a 14.4 meters per second. So we're gonna multiply it also with our 0.56 in here. That dots can be squared, plus 2 minus 9.8 meters per second squared, and then multiply it again with 2.1 meters. We can extend this one, our square root, then also our is over our negative 9.8 meters per second squared. That is the value for acceleration due to gravity. Okay, our next one here, next step, we can get negative 8.05 minus here square root of 105.96, that is over 9.8 meters per second squared. Okay. So we have still negative in here. Then we can get our value already for the time, which is amazing. We can get 1.87 seconds. Okay. So that's our value for time. We're happy with that already. And then actually this is 1.87 seconds. So now let's proceed already to our horizontal distance. Okay, so to do that, please remember the 1.87 seconds, everyone. And doing this one, erasing this first. Then we'll proceed now to our horizontal distance, which is for L. That will be our horizontal component, then times t, and that will be derived with L and our initial velocity, our time, which is 1.87. Please remember that. Then cosine theta. So what we'll do here is got 14.4. It's 14.4 meters per second multiplied by 1.87 seconds, and also multiplied by 0.829. Then we can get already our answer. Plugging this in your calculators, it's 22.32. Remember, because it's distance, that is meters.